Supersets, the opposite of a subset. Let's quickly recap what we learned about subsets. Remember, when we have two sets, A and B, and every element of B is also found in A, we say that B is a subset of A. We write this using the notation B is a subset of A. Every element of B is in A. Now, here's an interesting question. What if we flip our perspective? We've been looking at this relationship from B's point of view. B is inside A. But what about from A's perspective? From A's viewpoint, A contains B. It's the exact same relationship, just viewed from the other direction. Let's formalize this idea. If B is a subset of A, then A is a superset of B. That's it. It's not a new concept, it's simply a new term for the same relationship. Now let's look at the notation. On the left, we have the subset view. B is a subset of A. On the right, we have the superset view. A is a superset of B. Notice something important here. These symbols are expressing the exact same relationship, just from different perspectives. It's the same relationship. Let's make this concrete with an example. Consider the set numbers, which contains 1, 2, 3, 4, and 5. Here's our number set, with all 5 elements clearly visible. Now, let's define another set called evens, which contains just 2 and 4. Look carefully. 2 and 4, the even numbers, are both inside our number set. So we can say evens is a subset of numbers. Therefore, numbers is a superset of evens. Just like we had proper subsets, we also have proper supersets. A regular superset uses this symbol, meaning greater than or equal to. Think of it like the greater than or equal to symbol in arithmetic. A proper superset uses this symbol, meaning strictly greater than. Think of it like the greater than symbol. The key difference? For a proper superset, A must have at least one element that is not in B. Now, let's see this concept in action with something you use every day, the number system. At the center, we have the natural numbers. Expanding outward, the integers contain all the natural numbers, plus 0 and negative numbers. Expanding further, the rational numbers contain all the integers, plus fractions. And finally, the real numbers contain all the rational numbers, plus irrational numbers like pi and the square root of 2. Using superset notation, we can write this beautiful chain. The reals are a proper superset of the rationals, which are a proper superset of the integers, which are a proper superset of the naturals. Each set is a proper superset of the next. This elegant hierarchy, built entirely on the concept of supersets, is fundamental to mathematics. Let's summarize what we've learned. Supersets are simply the other side of subsets. If B is a subset of A, then A is a superset of B. They're equivalent statements. Proper supersets are strictly larger. A is a proper superset of B if A is a superset of B and they're not equal. Understanding supersets gives us a complete picture of how sets relate to one another. In our next video, we'll learn how to actually operate on sets by combining them together using the union operation. See you there.